Without without further ado, allow me to share my screen. All right, so does everyone see these three equations of interesting shapes?
Yes.
All right, great. So our goal is to figure out the value of each shape, because in this puzzle, every shape has a value assigned to it. For example, the square might be 4, the circle might be 5, and we're trying to figure out what each shape equals. So how could we start to figure out how to solve this puzzle? You guys have any ideas? Joyce?
The middle problem has two triangles, and 4 plus 4 equals 8. So I feel like the triangle is 8. I mean 4. Sorry.
Excellent. That is correct. All right. Then do you think we could figure out what the circle is too?
3, because 4 plus 3 is 7.
Excellent. All right, finish the problem, shall we?
So then the square is 2.
Excellent. You solved it. All right, that was fairly simple. Let's move on to one that is slightly harder.
Triangles are 3.
Yep,
The circle is 2.
yep.
Uh,
This requires a bit of thinking, huh? You can think of this as 2
4.
squares.
4.
That is
Square
correct. All right, so in case someone doesn't understand this, I'm going to elaborate just a little bit. So we know that the circle plus 2 squares equals 10. That means 2 squares equal 8, right? Because if you add 2 to the 2 squares and that equals 10, then 2 squares must be equal to 8. Then, since 2 squares equal 8, we know that each square is 8 divided by 2, which is 4, as Joyce have stated. Good job, Joyce. All right. This one, it's a little harder.
is 6. Apples are 6.
Yep. Uh-oh, I can't write on this.
Wait.
All right. Okay.
And then I don't know. I don't know what the bananas are.
No, Joyce, you do know. This is very similar to what we did in the last problem, right? Remember?
Oh, wait. So go back. So the banana is 4, I think.
That is correct.
Wait.
Because since the apple is 6, 2 bananas add up to what? 14 minus 6, right? So
Yes.
These two add up to 8, meaning each one is 4. That is correct.
So banana minus cherry equals 2. So 4 minus 2 equals 2.
That is correct.
Cherry 2 plus 6. And then banana 10.
Not
Wait.
quite. You're very close, but check your calculations a bit.
Hang on. That's 8. And wait a minute. Why is that 3 bananas and not 4 bananas?
Oh, wait. Actually, I did not even realize this. Joyce, you are absolutely correct. Okay, Lloyd, you got the right answer. Okay, so what we were assuming, what I was assuming was that I thought the bananas was like it's one entity, as in like this is one thing. So one handful of bananas 4. So in that case, we would calculate 4 plus 6 plus 2, which as Lois stated is indeed equal to 12. However, Joyce, you made an excellent observation. And that is, this is actually a bit more complicated than we think, because this would be 4 bananas, so 4 times bananas. And this would be actually 2 cherries, right? Will we count this as 2 cherries? Well, that doesn't really matter, does it?
No, it doesn't.
Yeah, but we would have to like kind of like recalculate this. It's a bit more complicated. Well, we still know the apples equals 6, right?
Yes.
Well, since the apples equals 6, we know that 4 plus 4 equals 8 bananas.
Mhm.
Bananas equals what? Equals 8, right?
Yes.
So someone
So
tell me what 1 banana is.
1.
That's correct. 1 banana is 1. That is correct. All right, then. Then if 1 banana is 1,
The bottom
then
banana is 3.
that is correct. We're adding 3. But we still kind of need this. We have to figure out what the cherry is.
Oh. What? No, the cherry's 2.
That's correct. I was just testing you to make sure you can solve it a second time. Yeah, but anyways, then what would the answer be?
11.
That's right. The answer would be 11. Great job, guys. This is going smoother than I thought it would. David, you want to go over the next couple ones?
Sure.
All right.
So Joyce, how are you gonna solve this question?
So 30 divided by 2 is 15. So the banana is 15.
Correct.
And then the cherry is 10 because 20 divided by 2 is 10. The apple is 4. So it's 15 times 10 times 4.
It's actually a plus sign here. Plus 10 times 4. So you get 55, right?
Wait, what was the confusion? Joyce, what was the question? Wait, what's the problem?
Oh, Joyce mistaken the plus sign for the multiplication sign.
I didn't see the plus
Oh,
sign.
oh, that's fine. That's fine. Wait, but you guys, wait, let me just backtrack a bit. You guys know the order of operations, right? Are you guys familiar with it, or should we go over it real quick?
I forgot what that is.
All right, that's fine. All right, I think what David just wrote is gonna help us with that. All right, Lloyd knows what it is, but we're gonna go over it real quick for Joyce, shall we? All right, David, do you want to explain it or should I do it?
I can explain it.
Okay.
So BOMDAS is basically a simple way to memorize the order of different operations. So the S here represents subtraction, which is the minus sign. The A here represents addition, which is a plus sign. Some people see that because the order from the start to the end is the order you should do the operations. So that doesn't mean like you should do you should add stuff always before subtracting them, but it basically means that, for example, B represents brackets. If you have a bracket, you should always do the stuff inside of the brackets and then do addition and subtraction. Moving on, you have D, which represents division. Division. And then you also have M here. It looks like an N, but it's M, which represents multiplication, which is the X sign. And O here represents powers. I mean, you could this is called operations, but it's basically powers, like 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. Do you guys
That's right,
all?
Lloyd. It's exponents.
Yeah, exponents. And then B here represents brackets. So when you solve questions, always go from the left of the bomb dash to the right of the bomb dash. Meaning you should do the brackets first, and then the operations, and then the multiplication. Well, actually, you could do like the sequence for multiplication and division doesn't really matter. It's just an easier way to remember it. But remember that like you could do multiplication or division like any way you want. Like the sequence for multiplication and division doesn't really matter. And so is the sequence for adding and subtracting. So
All right,
yeah,
Lloyd
PEMDAS.
wrote PEMDAS. And Joyce, that is indeed another acronym we can use to remember that. And I think that's also what like most schools teach as well. But you can also use David's bomb does, but you can also use PEMDAS, and PEMDAS stands for parentheses, exponents, multiplication, division, addition, subtraction. And as David has said, you do parentheses first, exponents second, multiplication and division. You do these at the third step. It doesn't matter if you do division first before multiplication, but in general, you do these two as the third step. After that, you do addition and subtraction. And again, as David said, it doesn't really matter what order you do these two. All right, does that make sense? Clarifies it a bit.
Yes.
All right, great. We solved this one, right, David?
Yeah.
All right, then. Why don't you go ahead with the next one?
Lloyd, do you want to try this question? All right.
Oh wait,
Yeah.
Loy is a chat guy, so I'll read his chats to you. So he got mushroom equals 12.
Yep.
All right, Loy, that's great. Tell us what two pairs are. Let's solve for one pairs since we're gonna need one. Yep. Well, Loy, two pairs is equal to 6. So what is one pair equal to? That's right. One pair is 3. All right, Loy, what is the tongue? It's a very interesting symbol. 4. That's right.
Correct.
So, Lloyd, tell us the answer. 19. David, is that correct?
Yeah.
All right. Great. Good job, Lloyd. All right. Let's do one more of these simple ones. It's gonna gradually become harder.
Halbo, do you want to try this one?
Albo, do you want to try this one?
The apples, the watermelons will be 20, 20, and 20. The
Yep.
apple will be 10. And the grape will be the grape will be 6. The grape will be 6 because 6 plus 10 is 70. So 20 plus 40 equals 60 minus 6 is 54. 4 because there are 2 apples and 2 watermelons.
That's correct.
That is indeed correct. All right. Just before we move on to the next one, does anyone have any questions about this? Should be fairly simple, right?
Yes.
All right, sounds good. All right, we have a puzzle that is a little trickier. Does anyone want to volunteer?
Wait, so the candy watermelon is 1, right?
The candy watermelon. Oh yeah, this thing.
Yes.
That is correct. It is indeed 1.
And then watermelon plus 9. So then the fish is 5
Huh. That's right, but tell us why, Joyce.
because the watermelon is 1 and 1 plus 9 is 10. So which means 10 divided by 2 is 5.
That is correct. Indeed. All right.
So then the candy fish is what?
Well, we can figure out this one, right?
So 26 minus. Oh, so the lollipop thing is 25
That's right. Wanna tell us why, Joyce?
because the watermelon's 1 and then 26 minus 25 equals 1.
That is correct.
And then
All right, one more variable.
5. Wait. 5. 5. It's 10. And then if the whatever those bean candies are is 15.
That is correct. Lloyd, yep, you got it. It's 15. All right, then. One of you tell us the answers. Let's see who's faster. What is the answer?
So 25.
Oh,
20.
Lloyd got it.
20. Yeah, well,
It's fine. Finish the problem, Joyce. Let's hear what your solution is.
so 25 minus 15 is 10.
That is. That
Wait.
is correct.
Okay.
Oh yeah, I think okay. I'm assuming Lloyd, you did a typo, but in that case, I mean, Joyce, you won technically.
Yay.
All right, good job to you both, though. Good job to you both. All right. Okay, we have one that's in a slightly different vein. It's a lot of multiplication, but you guys should be able to solve this.
Okay, yeah. So the square is 9.
Wait, are we sure about
Wait,
that?
what?
Wait, Lloyd, tell us why the square is 9. You can feel free to unmute if you want. It might be quicker to type. I mean to say rather than type. Okay, Lloyd. I see where you're going. Okay, so it's a very good idea, right? Because you're going off of what we have been talking about in like the past 7 puzzles. It is that would be the correct answer if the sign was plus instead. However, in mathematics, there is multiple ways of writing the multiplication sign. You can also write it as a little dot like this. In this case, the dot is representing multiplication. So
Uh,
So the question we would be asking right now is, What number, when you multiply it by itself 3 times, gives you 27? Or some people would also write this as, what number cubed raised to the power of 3 give us 27? Start by experimenting with small numbers. Would it be correct if the square is 2? Lloyd, would 2 work as an answer for square? No. Why not? Why doesn't 2 work? Joyce, do you think 2 works?
No.
Right. Because 2 times 2 times 2 is equal to 8, right?
Mhm.
If it was 2, uh-oh, I can't annotate. Right, just like Lloyd said. If it was 2 times 2 times 2, we would get 8, not 27. All right, so 2 doesn't work. What about 3? Does 3 work? Yes. Lloyd claims that it does work. Joyce, what do you think?
Wait. Yes.
You think it works? Well, guess what? Me too. I also think it works. David, do you think it works?
Yes.
All right. Looks like
It's
we all
also
agree.
part of the exponential to write it in this way.
Indeed. As David has pointed out, you can also write 3 times 3 times 3, which is equal to 27. The reason why it works as 3 to the power of 3. And indeed, we have now figured out that the square is equal to 2. I mean, sorry, equal to 3. Hooray. All right, now let's figure out the triangle. Okay, Lloyd claims that the triangle is equal to 2. Joyce, what do you think about that?
2, 8. Yes, she's right.
All right, looks like we all agree. Well, I also agree because since 3 triangles multiplied together and then multiplying by 3 gets you 24, that means multiplying 3 triangles together and ignoring the rectangle, sorry, the square, means that 3 triangles multiplying together gives you 8, right? Because 24 divided by 3 equals 8. And as we have found here, 2 would be the answer that satisfied this condition. So that is correct. Triangle is equal to 2. All right, then. What is the circle? Lloyd says that the circle is equal to 8. Joyce, what do you think about that?
Uh, doing the math. 6, 6, 6. Yeah, I
Wait, did you say yes or no?
yeah, yes, I think. I think.
David, do you agree? Do you think it's 8?
Nope,
Why not?
Oh, wait, no, I did the math wrong.
because 3 times 2 is 6. And if you divide 96 by 6, you get 16. Because 6 times 10 is 60. And 6 times 6 is 36. Yeah, 36 and 60 together, and you get 96. So these two circles must equal to 16. So do you guys know what is the circle now?
Loy claims that it is 8. Remember, Loy, this is this is multiplication.
So does the circle equal 4?
That's right. Loy, I think you're still thinking of the dot as addition, and indeed, if it was addition, it would indeed be 8, right? Because 2 circles added together is equal to 16. So, right, you got it. Bingo. 4 times 4 equals 16. Yeah, so just remember that when we see a dot in mathematics, it means multiplication. It's just like a shorthand way to write multiplication. And also when you study algebra, you will use the variable x. And so if you write the multiplication symbol, it will become easily confusing, which is why mathematicians started using this little dot right here. But anyways, someone tell me the answer. Loy claims it is 14. Joyce, do you agree?
4, 3.
Halbo claims it's 10. Ooh, we have a disagreement. What is your opinion, Joyce? We have a split right here. I didn't quite catch that. What was that? What did you say? Joyce, hello? Okay, I think Joyce might be lagging a bit. So, David, what's your opinion? Who do you think is correct?
I think Halbo was correct.
Huh? How come?
Well, I think Loy still Loy might have like misremembered the circle as 8. So when he did the thing, he did 3 times 2, which is 6, plus 8. That's what he did, which in this case, indeed equals to 14. But actually, the circle equals to 4, right? So it's 4 plus 6, which gives you 10.
All right, hooray for Halbo. However, Loy, you were very close. And if we have found 8 for the circle instead, you would be absolutely correct. So good job to you both. And let's move on to the next one, shall we? So this one will involve a little bit algebra. You can bring through it, but it would also help if you use a bit of algebra. And we're gonna show you how, but why don't we try to solve it without using algebra? What do you guys think the 2 shapes would be? Joyce, you wanna try?
So if the bottom one's right, then what? Okay, so I just said 6.
Which one's 6?
Loy just said 6. I didn't say anything.
Oh, no, but like, we're curious as to what you have to say, right, Joyce? What do you think?
So the square plus the square equals the blue thing.
Okay. What does that mean, Joyce?
So wait. So,
What is a square plus a square, Joyce?
this,
It's 2 squares, right?
yes.
All right. Okay, so this is equal to square times 2. All right. Does this look good to everyone? All right, I hope it is. All right, anyways. All right, then. So how will we finish the problem?
So since the blue thing is 2 of the red squares,
Okay.
my brain is hurting.
You got this. You have 2 apples and you're adding another apple. Loy claims that it is a
Wait.
number I shall not tell you, Joyce. Good job, Loy. You got it. But let's let Joyce figure this out, shall we? Joyce, come on, you got this. It's very simple.
It is.
What is it?
I see how to do it, but I'm not quite sure.
Well,
Where
let's
to
think about
start.
it like this, right? Joyce, what is 2 squares? It's like 2 squares added together, right?
Yes.
So I have 2 squares and you give me another square. How many squares do I have?
3.
Right? So wouldn't this whole expression here equal to 3 squares?
Yeah.
Right? So what's the square?
Eh.
If you have 3 squares and it's equal to 12, how much is 1 square?
4.
That is correct.
Oh, was that
That
simple?
is correct. All right, good job. And that's actually how we're going to lead into our algebra discussion. Well, because you see, Joyce, what we did there, talking all about like 3 squares and 2 squares, is actually how you would begin your discussion on algebra. Because say that we call this square x, shall we? Like the variable x, like the alphabet, like W, X, Y, Z, like that. Like when we use variables in mathematics, variables, we use a random letter in the alphabet to represent a value that we do not know, right? So in this case, we do not know what a square is. We know it's equal to some number, but we don't know quite what it is. So we're going to call it x. We're going to say that it is equal to some number, and that number is equal to x. All right, is this first step clear to everyone?
Yes.
Great. All right, so since we also have this other shape and we know nothing about it, we're going to give it another variable. We're going to call the blue star thingy y, right? Like we know it's equal to some value, but we don't know what it is. So we're going to call that value y. Is this good for everyone?
Yes.
Great. All right, then. So we label our values as shown. All right, so what does this bottom equation tell us? Like, what relationship can we create between x and y given that y minus x equals x? What can we say about y and x? Lloyd, you have any ideas? Joyce? Think about how we talked about 1 square plus 1 square equals 2 squares. Halbo claims that we can deduce y equals 2x. Joyce and Lloyd, what do you think about this? Is y equal to 2x?
Yes.
How come? Halbo, tell us, why is y equal to 2x?
Because
Because
y.
x plus x plus y, so 2 of the x equals
Okay, that's very close. I am going to give an official description. Well, since y minus x equals x, we can add x to both sides of this equation, right? Because since y minus x, which is some number that we do not know, for example, if y was like 5, x was like 3, y minus x would equal 2. So y minus x is some number that we do not know. And we know that this some number is equal to some number that's equal to x, right? So y minus x is equal to x. So that means if we add x to both numbers, if we add x to y minus x and add x to x, the result will be same, right? The resulting two numbers will be the same. Is that clear to everyone? Do you guys understand what we're saying? All right, let us know if you have any questions. But anyways, this would imply that y equals 2x. And I often find that people find 2x very confusing, but what 2x means is 2 copies of x. So basically x plus x. And you can also think of it as if x was an apple, like the apple Snow White eats, then 2x would represent 2 apples. So remember, an expression like 2x simply means 2 copies of x. Joyce, tell me what this expression means. What does 4z mean, Joyce? Loy, what does 4z mean? If any one of you have an idea, feel free to tell us. Joyce and Loy, what does 4z mean? What do you mean by 4z? Huh. Well, Joyce, what do we mean by 2x?
There's wait,
You're on the right track. Yep, there's what?
z, so it's 4 z's. Wait,
That's
so-
right. That's
wait,
right. Say
wait.
that again.
4 z's.
That's right. Again, this, although it looks very confusing putting a number by a letter, it's a very simple concept. It's just saying that there are 2 copies of x. 2 copies of x. So again, if x were to be an apple, this would mean that you have 2 apples. So again, 4z just means that there are 4 copies of z. There's 4 z's. Very simple. But anyways, since y equals 2x, that would mean that y is equal to 2 copies of x, right? Then, since y is equal to 2 copies of x, we know we can substitute y equal to y into x. This is a term in algebra you wouldn't see when you study algebra. It's called substitution, or people also say substitute, but that just means that since we know y is equal to 2 copies of x, we can replace the y in the equation with 2 copies of x, or 2x. And we can write 2x plus x equals 12. All right, now going along with this idea of like 2x and 4z's, what is 2x plus x? Joyce, Lloyd, how about?
3x.
Okay, Halva says it's 3x. What do you guys think? Chris, what do you think? David agrees. Huh. Loy says 2x is 8. Joyce, what do you think? What is 2x plus x? What is 2 apples plus 1 apple?
3 apples.
So what's 2x plus x?
3x.
Bingo! Again, 2x is 2 copies of x. So if you add 2 copies of x to 1 copy of x, David agrees that it is equal to 3 copies of x, which is 12. So what is x? What is x?
4.
Great. I see a notification in the chat. Yep, Loy agrees. X is indeed 4. And in algebra, you can solve this equation, this fancy term called solving this equation, and you would divide both sides by 3 so that you cancel out the 3 timing the x, and you would get 3 over 3 equals 1, 12 over 3 equals 4, so x equals 4, which is what we got before. All right, then, someone finish the problem. What is y? Look at this. Joyce, you're smart. What's y?
Eight.
Okay. I don't know if you looked at Halvo's answer or not. Why is it 8?
Because 2x is equal to y.
Right. That is correct. All right, I think we all get this. We're going to move on to the next problem. This one also involves more algebra because it would be very hard to solve it without using algebra. So
Wait.
why don't we give this a new variable? We're going to call the square S and the triangle T. All right, David, you want to help explain this? I'm going to chill for a little bit.
Sure. Since we S here and T here, this is also T and this is also S. We're gonna do a trick here that I think is called parallel of systems or something like that, where you basically add up 2 equations or subtract them. So here we're gonna add up these 2 equations because the square S, this one here is a negative square, this one here is a positive square. So when we add these 2 equations together, it's gonna eliminate square, right? We're gonna get rid of square because a plus and a negative equals nothing. So we're gonna get T. Actually, let's write it this way. Since it's when we add equations, we add the left hand side together and then the right hand side together as well. So here we have S plus 3t plus t. All right.
David, just so you know, you could also use the text option in the annotations. It's to the left of draw. It would be like, it might be a little clearer, but feel free to do. Oh no, I think David lagged. Uh-oh. All right, then I'm gonna help him explain this. All right, so if you looked in the chat, I provided like a little basic background information on how this works. But basically, what we're saying right now is that there are two equations, right? We define a square as s and sorry, I am right. That is right. And we're gonna define the star as t. So we have two equations. We know that s plus 3t equals 10. And we also know that t minus s equals 2. Does everyone agree on that?
Yes.
Great. And as you can see in the chat, this system, we call these two equations a system. It's called a system of equations and two variables because it has two variables. And what happens if we add the two equations together? So like what happens if you add the left side to the left side and the right side to the left side? Joyce, what do you think happens?
Um,
And look at the s's.
oh,
What happens to the s's?
I don't know.
Well, Joyce, maybe if I type it again, it might help. I'm gonna write it in a slightly different order. All right, Joyce, what do you think happens to the s? Look at this.
Still not understanding what's happening.
Well, we add s and we subtract s, right?
Yes.
So it's like saying I give you an apple and then I take it away from you. It's so mean, but like I did it anyways. So if I give you an apple and then take it away from you, how many apples do you have?
0.
Right. So if you start with one s and you subtract one s, how many s's do you have?
0.
Right. So doesn't this just like cancel out?
Yes.
Do you see it now?
No.
Wait, yes or no?
No.
Okay,
I still don't understand.
what do you not understand?
I know you said that the S, that part of the S is gone, but then I still don't understand. I
Is it confusing that like we added the equations?
kind of, yeah.
Okay, I see. Well, what we can think again, I always like to make this analogy. We can think of an equation as like a scale like this, like I'm drawing right now. And we're weighing things, right? And we always want the two sides of the scale to be equal. And that's actually what we want the two sides of the equation to be. We want them to equal. Because if it's equal, the scale will be balanced, right? But if it's not equal, uh-oh, then what's gonna happen? Right, the scale isn't gonna be balanced, right? Say you have one circle on the left, but 3 circles on the right. The right side is much heavier, so it's not gonna be balanced. So it's not an equality, right? So in our case right here, we have s plus 3t equals 10. So as we have already stated, s is like some number we don't know, and t is also some number we don't know. So s plus 3t is 1s plus 3 copies of t. So that's equal to some number that we don't know. And we know that this sum number is equal to 10, right? And the second equation is saying that we know that t minus x is some number that we don't know, and that this sum number is equal to x, is equal to 2. But regardless, these two sides are equal, right? These two are equal numbers. They both equal 2. So, and the same thing with the first equation, they both equal the same number. They're equal to 10. So if you add two numbers that are the same on both sides, so if you add 10 to plus 2 on the right side, and you add 10 plus 2 on the left side, wouldn't the two sides still be equal? Wouldn't the two sides still be balanced? Does that make sense?
Yes.
Okay. That's good. But like basically the idea is saying that since s plus 3t is some number, and this sum number is equal to the sum number on the right, so these two numbers are equal, they're equal to each other, they're the same number, they have the same weight. Then when we add both sides a number that's equal, so like t minus s is equal to 2, they're the same number, they're equal, they have the same weight. Then if we add these two together, the balance is still balanced and they have the same weight. Does that make sense?
Kind of.
All right. When you learn algebra, you'll learn much more about this. But for now, we added these two equations together and we arrived at this. And as we have just shown, s cancels out with s. What is 3t plus t, Joyce?
40.
Excellent. You are catching on to algebra. That's great. That's equal to 12, right?
Yes.
So t is equal to 3. Agreed?
Yes.
All right. So if t is equal to 3, what's s?
1.
That's right. All right. So what is 1 plus 3?
4.
All right. I challenge you to prove that 1 plus 3 does not equal to 4. But for now, we shall move on to the next question. All right, David, you want to go over this one?
5 circle is 5.
Yep, sure.
All right.
Joyce, the circle is 5, as you said. That's correct. What should we do next?
So the square has to be circle times 2 squares put together.
Oh, remember the order of operation? The
Oh.
plus signs go last, so you have to do this first.
2, wait, but 5 times 8.
There's actually a trick we could do here. Do you want to keep on trying, or do you want to hear about the trick?
I need help.
Okay. So don't think about the circle as a circle. Think about it as a number. Think about it as 6 times the square.
Wait, no, let's just use
Plus-
5. We know it's 5, David. It might be because we know it's 5.
Oh wait.
Yeah, like as David said, don't think of it as a square. Think of it as a number because it indeed is a number.
Yeah. 5 times the square plus another square equals to 12. So what should we do next? 5 times the square plus another square equals to 12. What does this mean?
So is the square 2?
Yes, but how did you get to this answer?
I did the exact opposite of what you told me to.
Did you just do trial and error? Like did you try all of the numbers?
Yes.
All right, this works, but if you're dealing with dealing with like much bigger numbers, or the square wasn't such a small number, if it was like 269, you'll have to try multiple times before reaching the answer. The hint, as Hempel said, is to combine the two squares. When you combine,
Sorry, guys, I messed up on the frame. I'm gonna share it back right now.
this is 5, 5, 5. When you deal with this thing, you can actually think about 5 squared plus another square. Yep. Think about it this way. When you have when you have five squares, you're essentially adding up five times the square. You're essentially adding up 5 squares, right? And then this becomes this, right? 5 times square equals to 5 squares plus together. If you add another square, what does this become, Joyce?
Eh.
Did you get it? Because if you times, because 5 squares, what is timing? It's essentially adding up numbers, the number like number of times, right? For number of times. Right here you have a 5. If you have 5 times the square, you're essentially doing the operation of plussing squares together for 5 times, right? Plussing 5 squares together specifically. Is that right?
Yes.
So if we have 5 squares here, and we plus another square, which is this one, what do we get? Let me make this clear. This is the other square. This is the square. The yellow square is unique. What does this become, Joyce? 1, 2, 3, 4, 5, 6. How many squares do we
Yes.
have?
All right, Joyce, you seem to be a little stumped. Let's think about it like this. Let's replace the squares with apples again, shall we? You have 5 apples, and I give you another apple. How many apples do you have?
6.
Bingo! Now, I use some sort of magic and I change your apples back to squares. How many squares do you have?
6.
Bingo. So 6 squares equals to 12. David, please continue.
All right. Okay. 6 squares equal to 12. So what does each individual square equal to? Joyce? We can divide both side by 6, right? We divide both side by 6. We get a single square here. And when we divide the other side by 6 as well, we get 2. Do you understand this, Joyce?
Yes.
All right. So each square equals to 2. Now we move on to the next step.
Five
How
times
should we solve this?
five.
Joyce?
5 times 2 is 10. And then uh 10 minus
Let's call the triangle X, shall we? $45.
I'm not so sure about that. I'm sure David disagrees. But it's a interesting guess.
That's not quite correct, Roy. Maybe I should explain this first because it's quite a complex concept, but it's similar to what we did up here. Imagine instead of having a single square here, you had square times 2.
so 2 times 5 equals
Or actually we could there's 2 ways. There's 2 ways to do it. We have a much more complex yet astonishing way, and we have a simple way. Which way do you guys want to use to solve this question? Joyce, the simple one or the more complex one? All right, I'm gonna do the simple method here first. So 5 times 2, we get 10, right? The side we
Yes.
have don't think about the circle as a circle. Think about it as 5. So we have 5x here. 10 minus 5x equals to 5. Now this is pretty easy, right? We subtract 5 from both sides and we get 5 minus 5x equals to 0. We plus a 5x to both sides and we get 5 equals to 5x. Now I'll just divide both sides by 5. We get x equals to 1. So yep, Lloyd, that's correct. X equals to 1. So the triangle equals to 1. But actually, there's a much more interesting way to solve this question. Because we don't have much time here, I'm just gonna go over it quickly. All right. So yeah, we have a 5 here, and wait, never mind. Actually, I was thinking about actually the method I was thinking about is used to solve for the circle if we didn't know what the circle was. But
Well, actually,
since
I
we-
think, David, there is indeed a very cool way to solve this. And I think what we can do, guys, is remember what the distributive property is, guys? Joyce, do you remember that? Lloyd, do you guys remember the distributive property?
Yes.
Right? Are you guys familiar with this formula? A times B plus C equals AB plus AC? But basically, notice how this is exactly this formula up here. So basically, we can just write the circle is A. The triangle is B. I mean, sorry, the square is B, the triangle is C. So doesn't that mean that we can factor the circle out? And instead we would have B minus C. So wouldn't this equation be equal to a circle times square minus triangle? Right? Does that make sense to everyone? Joyce, does that make sense? All right, hopefully it does. But anyways, since a circle times a square minus a triangle is equal to a circle, we can just divide both sides by the circle. So we get that a square is equal to a triangle. A square is equal to 2, so triangle is equal to 2.
Wait, I think there's how about you made a mistake here? Because if you divide both sides by the thing, you get 1 here, right? So 1 here.
Sorry, my bad. I made a very silly mistake. All right, yeah, that is correct. If we divide both sides on the right side, we would end up with a 1, right? Because if you divide both sides by a circle divided by a circle is like 5 divided by 5, or 6 divided by 6, and that's equal to 1. So a square minus a triangle is equal to 1, but we know that a square is equal to 2. So 2 minus what equals 1? That's 1, right? So triangle is 1. Thank you, David, for catching that mistake. That was very silly. But does that make sense to everyone? Joyce, do you understand what we just did?
Yes.
All right, great. We're really running out of time here, so if you guys want to leave, that is completely okay. But if not, we have a few more puzzles. We're gonna count to 10. If you don't leave, we're gonna keep going.
Bye-bye.
Okay. All right then. Lloyd, are you going to solve more puzzles with us? Yes, I don't know. All right, Lloyd, why don't we keep on solving this one? All right, shall we? All right, Lloyd, as the only student left in today's class, what is the T-Rex? 9. Great, Lloyd, I am always impressed with your impressive speed. All right, what is this like octopus or I don't know, dragon thingy here? It would be Hugh, right? Right, it is equal to 2. So since one monster is equal to 2, 2 monsters would equal to 4. So 4 minus 9 times something is equal to 4. Huh. That means this entire chunk here is equal to 0, isn't it? Because 4 minus a number is equal to 4. That means this number must be equal to 0. But we know that the T-Rex is equal to 9. So that must mean that all of these little ghosts here are all equal to 0, right? Because if 3 of these are equal to 0, every one of them must be equal to 0. Therefore, we know this one is 0, meaning that the answer would be 9 times 4 plus 0, which is 36. Right, you got it, Lloyd. All right, do you want to do another one or should we go bye-bye? We have a very hard one here. Okay, all right, Lloyd. I love that you're up for the challenge. All right, I have my annotating pen ready, so just type into the chat answers and I shall write them down. 3. What is that for? Is that for the Okay, Lloyd, I think you're very close, but not quite, right? Because if one eggplant is equal to 3, that means half of it would be 1.5, right? But you're very close. What if we say that one eggplant is equal to 4 instead? Would that work? 2. Yep, that is correct. If one eggplant was equal to 4, half of it would be 2, as you said, which would mean that this would make sense. So yes, Lloyd, that's correct. One eggplant is 4. All right, let's use what you just did. So what is an orange? 4. That is correct. One orange is 4, meaning half of it is 2. 4 minus 2 is 2. That's right. All right, apple. 2 apples plus half an apple. Ooh, this is a tough one. 8. Lloyd, do you mean this entire thing is 8? Or do you mean one apple is 8? Is 8 2 apples or 1 apple? Well, it would actually be 2 apples, right? Because if each apple, right, that is correct. If 2 apples is 8, 1 apple is 4. So half an apple would be 2. So exactly. Lloyd, you're doing very good. You're very smart. So the answer would obviously be 4 times 4 times 4. Mental math, Lloyd, what is it? Come on, Lloyd.
56.
That's very close, Lloyd, but it's actually 64 because 4 times 4 is 16 and 4 times 16 is 64. But yes, Lloyd, you solved it. You solved all of our fruit puzzles, and you are now officially a pro fruit puzzle solver. But yeah, good job, Lloyd. You like solved all of these. Good job. Bye.